Hello friends and dear students, I welcome you all to my channel. I hope you're all well and your studies are also going on well. This is part 2 video on the chapter of linear equations in two variables where I will be solving 14 problems based on the textbook problems of exercise 7.2 and some selected problems from the supplementary textbook problem books, that is MCQs practice exercise, MCQs in mathematics by RD Sharma. In the all these problems are based on part one, where I discussed about the solutions of linear equation. So this video is part of the playlist CBSE Maths for class 9, following the textbook of author RD Sharma. If you find this video beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel. And in that case, do not forget to press the bell icon so that you will be notified by my future videos. Okay. So the first problem says that if x is equal to if x equal to 2 alpha plus 1 and y equals to alpha minus 1 is a solution of the equation 2x minus cy equals to 0, find the value of alpha. Okay, we know that when we are given a solution, the root of a linear equation, the values of x and y of the root or solution will satisfy the equation. So we must have 2 multiplied by the value of x of the root is twice alpha plus 1, and then minus 3 in the for y we will put the value of the corresponding value of y of the root, which is alpha minus 1. This is equal to 0. So if you see, we get a linear equation in alpha. From here we can easily solve for alpha. So this is 4 alpha plus 2 minus 3 alpha plus 3 is equal to 0. This implies alpha is equal to minus 5, but the answer is minus 10. Minus 3y. Minus 3 alpha plus 3 equals to 0. So we are getting alpha is equal to minus 5, but the answer is given as minus 10. How come? Is the solution of the equation 2x minus 2y is equal to 0. So we have 2 into 2 alpha plus 1 minus 3 into alpha minus 1. It must be equal to 0. So we have 4 alpha plus 2 minus 3 alpha plus 3 equals to 0. So alpha, I don't know. My answer is coming out to be alpha equals to minus 5. If you think I have done any calculation mistake or applied concept incorrectly, then please feel free to let me know in the comment section. I will really appreciate that. To my understanding, I think I have correctly solved the problem. The alpha is coming out to be minus 5. It could also be a possibility that I have incorrectly mentioned the answer. I have incorrectly copied the answer from the book. Anyway, let's see the next problem. If x equals to 1 and y equals to 6 is a solution of the equation 8x minus ay plus a square equals to 0, find the value of a. We see in the given linear equation, there is an unknown or unknown constant a. We have to find a, where we are given that x equals to 1 and comma y equals to 6 is the root of the equation. So it must satisfy the equation, given linear equation. So we must have 8 multiplied by 1 minus a. For y, we will put 6, and we have plus a square is equal to 0. So we are getting a quadratic equation in the variable a, from where we can easily solve for a. So this implies a square minus 6a plus 8 is equal to 0. We can easily factorize. Using factorization method, we can solve for a. So this will be a. After factorization, a minus 4 multiplied by a minus 2 is equal to 0. So we know that we will have two values of a. A will be equal to 2 and 4. Okay, let's see the next problem. Question number 3. Let y varies directly as x. Let y varies directly as x means this is concept from the direct and indirect proportion, or direct or inverse variation. So when y varies directly at x, we mathematically write it as x. Now this implies that we will have y is equal to some constant k multiplied by x. When y varies directly, y and x are two variables. If y is varying directly with x, we will always have y equals to k into x for some constant k. Okay. So y equals to k, kx is obviously a linear equation with two variables x and y. So we are having the linear equation we are having is y minus kx is equal to 0, even though we do not know at this point what is the value of k. Possibly we can find the value of k from given other information. It is given if y equals to 12 when x equals to 4. This means that from the equation, this equation, when y is 12, when x is 4, then y is 12, which means that x equals to 4 and y equals to 12 is a root is a root uh, is a root of y minus kx is equal to y minus kx is equal to 0. Okay. So this implies we can satisfy. So x equals to 4 and y equals to 12 must be a root of y minus x, y minus kx equals to 0. So y x equals to 4 and y equals to 12 will satisfy the linear equation of the variables y and x. So we must have 12 minus k into 4 is equal to 0. So this implies 4k is equal to 12. This implies k is equal to 12 by 4, which is equal to 3. So we have found the value of k. So this implies the linear equation in y and x becomes y minus 3x is equal to 0. Now it is asking what is the value of y when x equals to 5. What is the value of y when x equals to 5? That is, when if I put x equals to 5 in this linear equation, then what will be the value of y? So putting x equals to 5, let's say this equation we want, x equals to 5 in equation 1, we get y minus 3 into 5 is equal to 0. So this implies y is equal to 15. Y is equal to 15. So when x will be 5, the value of y will be 15. Okay. Let's see the next problem. Question number 4. Check whether the following are solutions of the equation 2x minus y equals to 6 or not. So the given linear equation in the two variables x and y is given to be 2x minus y is equal to 6. Let's convert it into the standard form. So 2x minus y minus 6 is equals to 0. Okay. Now we have to check whether the given points, the given ordered pairs of the values of x and y are roots of or roots or solution of this linear equation or not. So if how will I check that? If I substitute the given values of x and y, if I substitute the values of x and y from the ordered pairs in the given linear equation, if the LHS comes out to be 0, when the linear equation is in standard form, this linear equation is in standard form. If after putting the values of x and y from the given ordered pairs, if the LHS is 0, then we can say that the ordered pair is a root or solution of the equation. So for the first one, let's see 2 into 3 minus 0 minus 6 LHS. This is LHS. We have to check whether the LHS is coming to be 0 or not. LHS is this. This is equal to 6 minus 6, which is 0. So therefore, the ordered pair 3, comma 0 is a root. I am giving a right sign, meaning that it is a root. Okay. The second ordered pair. For the second ordered pair, let's see what is the value of the LHS of the given linear equation. 2 into x, x is given as the ordered pair, value of x is 0, minus 6, minus 6. This is 0 minus 12, which is not equal to 0. So therefore, this is not a root. This is not a root. That is 0, comma 6 is not a root of the given linear equation. I am not going to do this 3, 4, and 5. I hope you have understood how to check it. So I'm skipping the 3, 4, and 5 parts. I'm sorry for that, but I hope you will understand. Okay. Question number 5. Find two solutions of the form x equals to 0 and y equals to a, and x equals to b and y equals to 0 for the equation minus 4x plus 3y is equal to 12. So the given linear equation is minus 4x plus 3y. In the standard form, it is minus 12 is equal to 0. Okay. To be more precise, it is minus 4, that is a is minus 4, b is 3, and the c is minus 12. C is minus 12. Okay. Now we have to find two roots or two solutions of this equation of the form x equals to 0, y equals to a, meaning the x value of x of the root will be 0, and the value of y of the root could be any real value. It is given as y equals to a, means a is a real value, any real value, but the value of x has to be 0. So how will I find how will I find the root where the value of the x is 0? Simply I will put x equals to 0 in the given linear equation and solve for y. So putting, this is the linear equation in x and y. So putting x equals to 0 in equation 1, we get minus 4, 0 plus 3y minus 12 is equal to 0. This implies we get a linear equation in y. So we will solve for y, and we get y is equal to 4. So putting the value of x equals to 0 in the given linear equation, we are solving for y, and we get value of y as 4. So then clearly then 0, 4 is a root of equation 1. Okay. So this is 0, 4 is the root of the form x equals to 0, y equals to a, where we have found y to be equals to 4. That is where a is equals to 4. Now let's find the root of the same equation of the form x equals to b and y equals to 0, which means that the value of y of the root will be 0, and the value of the variable x of the root would be any real number, that is denoted by b. How will I find? So I will put y equals to 0. I will substitute y with 0 in the given linear equation and solve for x. So minus 4x plus 3 into 0 plus, or rather minus 12 is equal to 0. This implies 4x is equals to 12. This implies x is equal to 3. So we can say that 3, 0 is a root of equation, the given linear equation, which is 1. So The root 3 comma 0 is of the form x equals to b comma y equals to 0, where b is 3. So we have found two roots of the given linear equation. One is one is 0 comma 4, which is of the form x equals to 0 and y equals to a. Another root we have found is 3 comma 0, which is of the form x equals to b comma y equals to 0. So the idea is that whenever you are given, whenever let's say you know that you know that the basic let's say you know that alpha comma let's say you know that some constant that 4 comma b some real number we do not know. If we know that 4 comma b is a root of a given linear equation, how do I find the value of b? I will just substitute the value of x as 4 in the given linear equation and solve for y. That will give the that will give and then 4 comma whatever the value of y we are getting, that value will be a root of the given linear equation. So essentially solving for y, we will get the value of b. Okay, let's see the next problem. Question number 6. For what value of c the linear equation 2x plus cy equals to 8 has equal values of x and y for its solution? It is saying that 2x plus cy plus 2x plus cy minus 8 is the given linear equation in the standard form, and it is asking that what should be the value of c. C must be a constant, so that all the roots of this given linear equation will be of the form k comma k. That is both that is the value of x and y of the root will be same equal. So let's say k so all the roots of the given linear equation will be of the form k comma k, where k is a real number. So let k comma k is a root of, let's say, the given linear equation. We are naming it as equation 1. So equation 1. So we will satisfy this point in the given linear equation, because a root, if an ordered pair is a root of a given linear equation, then the ordered pair, the values of x and y should satisfy the given linear equation. So we must have 2 into k plus c into k minus 8 is equal to 0. This implies that k, if I take k common, 2 plus c is equal to 8. This implies k is equal to 8 by 2 plus c. K is equal to 8 by 2 plus c. For what value of c? Then we are so for what value of c the linear equation has equal values of x and y for its solution. What value of c? Okay. Now instead of finding k, let's see what could be what we are getting as c. So this implies ck is equal to 8 minus 2k. So this implies c is equal to 8 minus 2k by k, where k we have assumed to be some real number. Now, what can the value of c be? What value of c? The linear equation has equal values of x and y for its solution. So has equal values of x and y for its solution. So whatever the solution, whatever the roots of the solutions of this given linear equation will be, in all the roots, the value of x and the y should be equal. Now, definitely, k cannot be 0. we are having c equals to 8 minus 2k by k. So this is some expression in terms of k. K cannot be 0 because then we will have a division by 0. So obviously k will not be 0, but if k is not 0, I can consider uh, k is not 0. I mean, there could be a lot of values of c, because I can put any value of k. I can put any value of k other than 0, and we'll get a value of c, which should, uh, and that value, let's say we are having this. Okay, so if I let k equals to 1, this will imply that c is equal to 8 minus 2, which is equal to 6. So this means that if the value of c is 6, then if the value of c is 6, then what can the value of x and y be? It is saying that has equal values of x and y for its solution. Equal values of x and y for its solution. If k is 1, if I put the value of k as 1, I'm getting c equals to 6. So then the linear equation will be 2x plus 6y is equal to 8. Now, in this linear equation, I think I have to solve this problem in a different way. Now, please note that it is saying that if, just imagine what can the linear equation of two variables x and y be, so that all the roots are having the x values and y values are equal. So we assume that, so all the roots of this equation, whatever the value of c be, for the required value of c, 2x plus cy plus is equal to 8. No, see, what can the how will the linear equation in two variables x and y look if all the roots are having equal values of x and y? So definitely that equation, the linear equation of two variables x and y, where all the roots are having equal values of x and y, has to be y is equal to x. Y is equal to x. That is the only. This is the only linear equation where now this is one form. I mean, as I said, discussed in the previous video, that there is no unique representation of a linear equation in two variables ax plus by plus c equals to 0. I can always multiply both the sides by some number, non-zero number, or divide by some non-zero number. So y equals to x should be the linear equation in two variables x and y, where all the roots will have equal values of x and y. Okay, but it is given that the linear equation in the linear equation in the two variables is given to be 2x plus cy is equal to 8. So these two equations must represent must be identical because the linear equation in two variables x and y, where all the roots will have equal values of x and y, has to be something like y equals to x. The y equals to x can also be written as 2y equals to 2x. I can write it as it could be like ky equals to kx. It could also be like y by k equals to x by k, where k is a non-zero number. Now, can I let's consider y equals to x is the linear equation. Definitely y equals to x is the linear equation in two variables where all the roots will have equal values of x and y. Now the given, so how can I, how now I have to compare the given equation 2x plus cy equals to 8. This should be identical to y equals to x. In and then what can, what should the value of c be, so that 2x plus cy equals to 8, this equation and the equation y equals to x are identical. Are identical. Okay. Now uh, mm, are identical. Okay. So from here, from here we are getting 2x is equal to 8 minus cy. 2x is getting equal to x 8 minus cy. And from the equation y equals to x, if I multiply both sides by 2, I will have 2y is equal to 2x. So on the left hand side, for the equation 2y equals to 2x, I see 2x is equal to 2y. And on the, for the given equation, 2x plus cy is equal to 8. When I see that 2x is equal to 8 minus cy. So 8 minus cy has to be equal to 2y. 8 minus cy. So I must have uh, 8 minus cy is equal to 2y. How will I find? How can I find the value of c? How can I find the value of c? Hmm, 0. No. 1. So what value of c? The linear equation has equal values of x about all solutions. Now, equal values of x and y for the roots. If I consider in this equation, if I take y equals to 1, if I take y equals to 1, I will have uh, if y is equal to 1, will imply c will be equal to 1, c will be equal to 6. C will be equal to 6. But 2x plus 6y, then the equation will become 2x plus 6y is equal to 8. But is it right that this equation has all the roots of the all the roots where the value of x and y is same? I don't think so. No, I don't think so. No, 1, 6, 1, 2, 4, 4, no. I don't know whether the problem is missing any information or not, because is the problem asking to find a very specific value of c that will make the given equation uh, to have all the roots where the values of x and y are same. Because any equation, any linear equation in x and y, if all the roots has to have the values of x and y equal, then it should be, it must be of the form y equals to x. Y equals to x. So y equals to x should be identical to the given equation 2x plus cy is equal to 8. From here, can we find the value of c? I don't know. So I'm sorry I couldn't solve this problem. Based on my understanding and knowledge, I am not able to find the value of c that will make the equation 2x plus cy is equal to 8 to have all roots where the values are of x and y are same. The linear equation has equal values of x and y for its solution. Equal values of x and y for its solution. I'm sorry, I will try to solve it in my offline and come up with a solution if I can. Let's see the next problem. Write the following equations in the form ax plus by plus c equals to 0. This should be an easy task. The given equation is 2y minus 3 is equal to root 2x. So I will bring everything on the left hand side. So it will be minus 2 minus square root of 2x plus 2y minus 3 equals to 0. This implies negative of root 2 into x plus 2y plus negative of 3 is equal to 0. So here, so this is the standard form of the linear equation where we are having a is equal to minus root 2, b is equal to 2, and c is equal to minus 3. Okay. Part B, the given equation is x by 3 is equal to y minus x by 2. I will do cross multiplication and I will have twice of x is equal to 3 into y minus x. Expand the right hand side. I have 3y minus 3x. Bringing everything to the left hand side, I have 2x plus 3x minus 3y is equals to 0. This implies 5x minus or plus minus of 3y is equals to 0. So this is the equation standard form where we are having a is equal to 5, b we are having is minus 3, and there is no c term, so c is 0. Let's see part C. X plus 3y divided by 3 is equals to 1. Again, I will do cross multiplication and I have x plus 3y is equal to 3. I will bring everything on the left to the left hand side and I have x plus 3y minus 3 is equals to 0. So this is the equation in the standard form, and where we have a is equals to 1, b is equals to 3, and c is equals to minus 3. Okay, let's see the next problem. Question number 8. The equation 2x plus 5y equals to 7 has a unique solution if x and y are. Has a unique solution. That is, has a unique solution if x and y are, which means that it will have only one solution, a single solution. Now, so what should be the condition? If this equation, if the equation 2x plus 5y minus 7 is equals to 0, this is the given linear equation. What should the values of x and y be so that this equation will have only one solution? That is, what will the values of x and y of all the roots should be so that this equation will have only one root or one solution. Let's see. Choice A is saying natural numbers. Now, if x and y, if the values of x and y of all the roots has to be natural numbers, then will this equation give a single root? Let's say if I put let x is equals to 1, x 1 is a natural number, let x equals to 1, this will imply that 2 into 1 plus 5y minus 7 is equals to 0. Solving for y, we will see that y is coming out to be 1. Y is coming out to be 1. So y is also natural number. So we get a root 1 1 is a root. 1 1 is a root where we are considering all of the values of x and y as natural numbers, and we are investigating what would be a root of the given equation when the values of x and y we are considering are natural numbers. Okay. Now you will see that if you consider any other natural values of x and y as natural numbers, then it will not satisfy the given linear equation. So the only root where the values of x and y are natural numbers of this given linear equation is 1 comma 1. So this means that the given linear equation will have a unique single solution, a root, if we consider the values of x and y as only natural numbers. So obviously the choice is A. Now you can easily verify the choice C is saying real numbers. No, if x and y are real numbers, we know that a linear equation has infinite number of solutions and roots if we consider the values of x and y to be real numbers. Choice B, positive real numbers. No, why? Why, if we consider positive real numbers, why any given linear equation will have infinite number of roots and solutions? Because the concept was I will choose a positive real number for x, and then put that value in the given linear equation, and I will solve for y, and I will get a value of x and y that should be a root of the given equation. Now there are infinite number of positive real numbers. So for the value of the chosen value of x, I can choose a value of x which is a positive real number. That choice has infinite number of possibilities. So I will definitely get infinite number of roots. Also, the choice D, the rational numbers are infinite. If I take any particular value of x as a rational number, I will get a value of y. I will get a value of y, which will also be a rational numbers. And since there are infinite number of rational numbers, I can choose infinite. There are infinite number of possibilities to choose the value of x, from where I will get another value of. I will get the corresponding value of y, which will also be a rational number. But in the case of natural numbers, the only value of x, the only value of x which is a natural number that you can consider, you can substitute in the given equation is 1, and then you will get the value of y as 1. If you consider the natural number, if you consider the value of x as 2, so let x is equals to 2. If I put x equals to 2 in the if I put x is equal to 2 in the given equation and try to solve for y, you will see that the value of y will not be a natural number. It will be something else. So the natural number 2, I cannot the value of x cannot be 2, from where I can get the value of y as another natural number. So you will see that I will have 2 into 2 plus 5y is equals to 7. This implies 5y is equal to 7 minus 4, which is 3. This implies y is equal to 3 by 5. 3 by 5 is not a natural number. So if you consider any natural number other than y for x, and if you solve for y, that value of y will not be a natural number. So if all the roots of the given equation are considered to be natural numbers, then we will get only a single root, which is 1 comma 1. Hence the correct choice is A. Okay, let's see question number 9. Any solution of the linear equation 2x plus 9 is equal to 0 in two variables x and y is of the form. So you can see in the given linear equation 2x plus 9 equals to 0, there is no y. This is clearly a linear equation in x. If we solve for x, we will have x is equals to minus 9 by 2. Now, if I have to consider 2x plus 9 is equals to 0 to be a linear equation and two variables in x and y, I know all the roots, the x value of all the roots will has to be equal to minus 9 by 2. So any root of the given equation 2x plus 9 equals to 0 will be of the form minus 9 by 2 comma k, where k could be any real number. Because if you, so any root or any point or any ordered pair of the form minus 9 by 2 comma k, where if you, this will always satisfy this the given linear equation. So the correct choice is A. A is the correct choice. Let's see question number 10. If a linear equation has solutions minus 6 comma 3 0 0 and minus 2 1, then it is of the form. Okay, so some roots are given and it is asking about the form of the linear equation. Now one way to solve is that you consider all the choices. You consider the choice A, you consider the given equation y equals to minus 2x and see whether all the 3 points, all the 3 given points, all the 3 given ordered pairs are satisfying the equation or not. If it is satisfying, then the equation, then it is a correct form of the linear equation whose roots are the given 3 ordered pairs, which are minus 6 3 0 0 and minus 2 1. But in this way, it will take a lot of time to individually verify whether all the given 3 ordered pairs will satisfy the given linear equations. We have 4 choices. Instead, you see that in all the ordered pairs, we see a pattern. The roots, that is ordered pairs, are minus 6 3 0 0, and we are seeing minus 2 1. Now, from this ordered pair, that is the root minus 6 3, what relation I can, so minus 6 is the value of x and 3 is the value of y. Can I quickly create a relation between the x value and the y value? Yes, I can, because I can see that x is nothing but equal to minus 2y. The 3 is the y value of the root and minus 6 is the x value of the root. So we can clearly see minus 6 is equal to 3, a negative of 3 into 2. Minus 6 is equal to negative of 2 into 3. Negative of 2 into 3. So where 3 was the value of y, of the root. So I can somehow I can say that maybe the linear equation could be of the form x is equal to minus 2y. X is equal to minus 2y. And okay, now we have to see if the linear equation is of the form x equals to minus 2y, then whether this linear equation is being satisfied by the other 2 points or not. You can easily make out the second root 0 0. Here also you will see that it will satisfy the equation x equals to minus 2y. Also the third point, third order pair, the third root is minus 2 into y. Here also you can see that minus 2 is equal to negative of 2 multiplied by the y value of the root, which is 1. So from seeing the x value and y value of all the roots, I can somehow create a relation between the x and y, which happens to be x equals to minus 2y. Now I have to see whether x equals to minus 2y if this equation is given in any of the choices or not. Yes, it is given choice C. It is given x plus 2y is equal to 0. From here, I can easily say x is equals to minus 2y. So C is the correct choice. X plus 2y equals to 0 is the linear equation for all the given 3 roots. Now remember that x plus 2y equals to 0 is not the unique representation of the linear equation. We can easily modify it by multiplying or divide it by some non-zero constant to both the sides of the equation, and it will remain the same identical equation. The representation will change, but essentially the linear equation will be identical, meaning it will give the same set of roots or solution. Let's see the question number 11. Any solution of linear equation 0x minus by minus c equals to 0 is of the form. Now the given linear equation is is looking a little weird. I mean 0 into x means 0. So 0 the given equation is of the form 0 into x minus by minus c is equals to 0, which is nothing but minus by minus c is equal to 0. Clearly, this is a linear equation in y, and we can solve for y, we must have y is equal to minus c by b. Now, if I have to consider this to be a linear equation in two variables x and y, I can clearly say that all the roots, the y value of all the roots has to be minus c by b. So, all the roots will be of the form k, comma, minus c by b. K comma minus c by b, where k is some, k could be any real number. So obviously, we see that in all the given choices, we are seeing m as the value of the x. Now m is definitely any real number. So the correct choice is D. D is the correct choice. Let's see the next problem, question number 12. If x equals to 1, comma y equals to 1 is the solution of both the equations 2x minus 3ay plus a square is equals to 0 and 4x minus 5y plus a square equals to 0, then a equals 2. Okay, so we are given that particular root which is y comma 1, the ordered pair y comma 1, sorry 1 comma 1, or it is also, we can say x equals to 1 and comma y equals to 1. So this is a root of two given equations. One equation is this and the second equation is this. From this information, we have to find the value of a. Okay. Now that we know that 1 1 is a root of 2x minus 3ay plus a square is equals to 0. This means that the ordered pair 1 comma 1 must satisfy this equation. So we must have 2 1 minus 3a 1 plus a square is equals to 0. So we get a quadratic equation in A. This implies a square minus 3a plus 2 is equals to 0. And we must be able to find two values of a. Since a square minus 3a plus 2 equals to 0 is a quadratic equation in A. Let's factorize. So this will be a minus 1 multiplied by a minus 2 is equals to 0. So this implies that two values of a will satisfy this equation, which are a is equal to 1 or 2. The value of a can be 1 or 2 from the fact that 1 comma 1 is a root. 1 comma 1 is a root of this equation. We are getting two possible values of a, which are 1 comma 2. Okay. Now remember that in the question we are asked to find the value of a. That will find the value of a so that the root 1 comma 1, so that the ordered pair 1 comma 1 will be a root to both the equations. So a single value of a will make the root the ordered pair 1 comma 1 as a root of both the equations. Now similarly, we know that 1 comma 1 is also a root of the other linear equation, that is 4x minus 5y plus a square is equals to 0. So the ordered pair 1 comma 1 must satisfy this linear equation, which means that 4 multiplied by 1 minus 5 multiplied by 1 plus a square is equals to 0. This implies that a square is equals to 1. This implies that a is equals to plus minus 1. So from satisfying the root to the second equation, we are getting a square is equal to 1. From here, we can say we have two values of a equals to plus minus 1. So now the question is, what will be, what should be the value of a so that the ordered pair 1 comma 1 will be a root of both the equation. Obviously, the common root for satisfying the ordered pair, satisfying 1 comma 1 with the first equation, first linear equation, we get two values of a 1 comma 2. And satisfying the ordered pair 1 comma 1 to the second linear equation, we get two values of a 1, 1 and minus 1. So obviously the common value in the two solution, in the first solution of a, we get a equals to 1 or 2. And in the second solution of a, we find a equals to 1 or minus 1. Obviously the common value of a, that is 1. If a is equals to 1, then only we will have the ordered pair 1 comma 1 will be a root. It will satisfy both the given linear equations, or it will be a root or solution to both the given linear equations. So the correct choice is a. The value of a has to be equal to 1. The value of a cannot be 2. From the first satisfying the ordered pair 1 comma 1 with the first linear equation, we are getting the value of a to be 1 or 2. 1 or 2. Now 2 cannot be the value of a, because if I put 2, if the value of a is 2, then and after putting a equals to 2 in the second equation, whatever that linear equation will be, it will not be satisfied by the ordered pair 1 comma 1. Also, if I put a equals to minus 1, a equals to minus 1 to both the linear equations, then the ordered pair 1 comma 1 will satisfy the second linear equation, but it will not satisfy the first linear equation. Okay. Let's see the next problem. If alpha beta is a common root of the linear equations 2x minus 2y equals to 2 and x plus y equals to 5, then the value of alpha to the power beta is. So it is given alpha beta is the common root of the linear equations. Okay. So alpha beta is a root of, it is given 2x minus 2y equals to 2. Now you can see in this given linear equation, I can easily divide both the sides by 2 and we will get a simpler version of the linear equation, and the linear equation will still remain the same. So whenever you see in a given linear equation that you are having in this form, you are having you can divide both the sides or multiply both the sides by some non-zero constant, and the linear equation will become simpler. You can always do that. So this linear equation is identical to x minus y is equals to 1. Okay. So now alpha beta is the root of the equation x minus y equals to 1. So this implies the ordered pair alpha beta must satisfy the equation x minus y is equals to 1. This means if I putting the, so this means nothing but alpha minus beta will be equals to 1. Okay, so I get a one relation between alpha and beta. Now alpha beta is also a root of the second equation, which is x plus y is equals to 5. So this means that the ordered pair alpha beta must satisfy the linear equation x plus y equals to 5. That means that we must have alpha plus beta is equals to 5. We get another equation 2. Now adding the equation 1 and 2, if I add the two equations, adding 1 and 2, what do we get? We get, so it is like when we add two equation, it works like this. So we have alpha minus beta is equals to 1, and we have alpha plus beta is equals to 5. When we add this two equation, we add the left hand side, we add the right hand side, and equate them. If I add the two LHS, we are having twice alpha is equal to, if I add the two right hand sides, we get 6. So this implies alpha is equal to 3. Alpha is equal to 3. And we also know using putting alpha is equal to 3 in equation 1, we will get putting alpha is equal to 3 in equation 1, we get 3 minus beta is equals to 1. So this implies beta is equal to 2. So we have found the value of alpha and beta. Alpha is 3 and beta is 2. And we are asked to find the value of alpha to the power beta. So alpha to the power beta is 3 square, which is 9. So the value of alpha to the power beta is 9, and the correct choice is C. Let's see the next problem, the last problem. If k square comma k is a common root of the linear equations x plus ky minus b equals to 0 and x by k minus 2y plus c equals to 0 for some real constant k not equals to 0, then which of the choices will be correct in terms of B and C? Okay, we will use the standard concept that when that a root always satisfies the given linear equation. So k square comma k is a root of both the two given linear equations. So let's say we are considering the first given linear equation, x plus ky minus b is equal to 0. K square minus k, where it is given that k is a real number, constant, a non-zero real number, constant. So if this is a root of this, then we must satisfy. So then the ordered pair k square minus k must satisfy the linear equation this. So we must have k square plus k into k minus b is equal to 0. So this implies we are having twice k square minus b is equal to 0. This implies we are having 2k square is equals to b. Let's call it the equation or result 1. Again, we know that this ordered pair is a root of the second equation, that is x by k minus 2y plus c is equal to 0. So the ordered pair must satisfy this given linear equation. So we must have k square by k minus 2 into k plus c is equals to 0. This implies k minus twice k plus c is equals to 0. This implies minus k plus c is equals to 0. This implies k is equals to c. From this we are having k is equals to c. Let this result be 2. Now using the result 1 and 2, can we create a relation between b and c? Obviously we can. We know that k is equals to c. Okay. We also know that 2k square is equals to b. This implies in the 2k square equals to b, I will substitute the value of k as c. So I have 2c square is equals to b. So this should be the relation between b and c. That is 2c square is equal to b. So the correct choice is D. D is the correct choice. So with this, it comes to an end in solving 14 standard problems based on the concept of solutions of a linear equation that I have discussed in the previous video, that is part 1 video. If you have not watched that video, then please do watch them. You will have the basic concepts of solutions of a linear equation clear. And unfortunately, I could not solve properly, or I could not solve one problem, which is question number 6, where I was asked to find the value of c, so that the given linear equation 2x plus cy is equal to 8 will have roots where the values of x and y are same. If you know, if you are able to solve this problem, then I will really appreciate if you can write something in the comment section that will help me. And if I can solve this problem offline, I will try to solve it offline and come up with and address and solve it in the next video. So if this video was beneficial, then please like it, share it with your friends. And once again, please support me by subscribing to my channel and do not forget to press the bell icon so that you will be notified by my future videos. Uh, in the next video, I will start about discussing the graph of a linear equation in two variables and how the graph of a linear equation in two variables, which is basically a straight line, how it is related with the roots or solutions of a given linear equation. Uh, Possibly, I will discuss all those concepts in multiple videos. Let's see how it goes. So I'm ending the video here. Thanks for watching, and until the next video, take care and bye.